Guy. Okay. So, went through the books on Thursday? Question mark? Yeah, Thursday. On Thursday, I went through everything that you turned in. You had time to work on progress checks 2 and 3. It was a handout. So, at the very least, even as I'm going through stuff, you still have this. Whether you did your work in progress checks 2 and 3, or you did it in your packet, you should have that done. Okay. I'm betting the majority of you did it on this because that's what I handed out. I don't think anyone was going to transfer it over into their packet, but I still got to say, it's in both places. So, today is kind of a last hurrah before we move into our next unit. I would like, there we go, for you to, do for me I'd like you to simplify two things that says, I know what was going on. There you go. Yeah. Progress check 2, 3. Okay. Hey, we had kind of one last hurrah to review through stuff, and I said, basically, we need to know all this before we move forward. On Wednesday, you're going to get a new packet, and that pretty much covers what we're doing for the second quarter. We're going to see, I think, a lot more handouts to supplement Unit 2, because we're going to get a lot of practice with it. It's kind of the nuts and bolts of algebra. So we got to make sure we're practicing. But this, and then our function relation stuff, this was a good chunk of first quarter. Those are two different problems.
No, you said so. And then when I get through them, eventually we are going to go back and get some of this done. Maybe if you have skills, resource management, we should go back and get some more. What word do you need to do this? this stuff won't really come back to haunt us until like April. So,
Okay. Yeah. We also wrote it down about 12 times. Packet, sections 1, 2, and 1, 3. Eh?
Automatic scientific calculator on the phone. Helps me with homework. I didn't use it.
Yeah, I know. That's why you're not supposed to use those. You use a regular calculator.
I know.
So, for that one, doesn't simplify some slice of decimal.
No. Simplify the radical. We spent a couple of days on that. It was a separate series of handouts because there was 2 extra handouts we did. Because 1-4 in our packet just said close enough. Then we showed you how to do it for real.
I forgot, like, since there's a negative down here, and this up here plus outside exponent, I forgot if I still put this on top, but also put the exponent on here before I put it to the top.
The order won't matter. Just do it in stages. Do it in stages. Okay? The order will not matter. Is it still over on the counter from last week? Because you didn't pick it up.
You handed it to me.
Okay.
One of the no names.
Yeah.
All of your folders?
What on the bottom?
For now, but then what do you do with that? We did that last week. Everyone had chance to do it together or with you, so we're just going to do a daily quiz to say, hey, look, do you know the first half of the semester? And then we're going to review equations today, or graphing them. So, do you know why they're all out and excused?
No, have not seen any of them.
Huh.
No, I saw Landon. Yeah, I saw Landon sweat out.
But every one of these are absent excused. So I figured it was something related. Huh. Law of large numbers.
Who sits there?
Um,
Because you just switched on
it was Kai, Landon, Damon's back there,
And Jackson.
Paxton,
No, Jackson. Jackson.
Jaden, and Jackson.
Yep.
I don't know. And remember, it's not enough to just puke out an answer on your paper and say, well, I think it's this. Oh, wasn't that? Whatever. You got time. Look through your notes. Look through your handouts. Look through your reviews. Think everyone's finally taken their stuff. Pretty sure. Yeah. I can give back the quizzes today, too. Okay. Now these should be each problem 2 minutes tops. I've done them 100 times by now. I'm going to go about a minute to finish up because we should not be 20 minutes into class still staring at it. Okay? If we're 20 minutes into class and staring at it, then we just don't know. Kevin raised an interesting question. Said, I know that they all get this too, but I also know that the negative means I have to flip this. Do I do that, then this, or this, then that? Yes. You get to do either one. Because exponents are repeated multiplication, and multiplication's commutative. The order I do that in doesn't matter. Okay? So maybe Kevin decides to bring this up first. Like that. Now it's positive. What happens when I have an x to the fourth times an x to the fourth, both on the numerator? What do I do with an exponent times an exponent? Add their exponents. Okay, so I turn that into 3x to the eighth y to the second to the second. Now I can say everyone gets that exponent. And say, you get a 2, and you get a 2, and you get a 2. But what is 3 squared?
9.
Okay. And what do I do with an exponent raised to an exponent? Rule number 3. We've written this stuff down 1,000 times. That's going to be x to the 16th because I have 2 groups of x to the 8th. I have 2 groups of y to the 2nd, so I've got y to the 4th. That was one way to do it. The other way would have been I could have given everyone that 2 right away. 3 squared x to the 8th, y to the 4th over x to the negative 8th, and then brought that upstairs. I'd still get the same thing. Like, it doesn't matter what order you do it in, so long as you're following the rules. For our other one over here, think the way that most kids had success with this was breaking it up by factor tree. If you know off the top of your head that 36 times 5 is going to get you your biggest perfect square that goes into 180, great. Some kids were okay with that. Most would rather say, nah, I'll just break it up. And say 9 and 2, 5 and 2, 9 is 3 and 3. And the reason that I wanted to break it up like that is because all the prime factors go together at the end. It's the square root of, I've got a 2, a 2, a 3, a 3, a 5. 2, 2, 3, 3, 5, and 7 x's. 1, 2, 3, 4, 5, 6, 7. So altogether, a pair of 2's, 1 comes out. A pair of 3's, 1 comes out. A pair of x's, pair of x's, pair of x's, comes out, comes out, comes out. So you combine everything on the outside. 2 by 3 is 6. X times x times x is x cubed. And sad, sad, 5 and x are still left in radical jail. Nothing else to do about it. They're just all by myself. There they are. So, that was one way. The other way, in case you went this route, just want to make sure there's options, is if I run down my perfect square list, the biggest perfect square below 180 is 169. You try 180 divided by 169. Nope, doesn't work. Try the next one, 144. Nope, doesn't work. 121, no. 100, no. 81, no. God, this sucks. 64, no. 49, seriously. 36, yes, it works! So I write this as 36 times whatever that was multiplied by. I want this to be even because I can take pairs of things out. So I'm going to call it x to the 6th with another x left over. See how it's still 7x's. So now The square root of 36 is 6. The square root of x to the 6th is x to the 3rd. Look who's left. See, this way involves less writing, but more thinking. This involves a lot more writing, but less thinking. They're both going to get you to the same answer. It doesn't matter which way you do it. It's purely a matter of personal preference. How's that for alliteration? Purely personal preference. Y'all in English class, please tell me you know what alliteration is. Where it starts with all the same letters. Many mangy mongrels mamboed on Monday. Yeah.
So, with the answer that we got, can't you put that back into like the and like simplify it even more?
Nope. Because outside radical land and inside radical land are two different dimensions. It's like outside of jail and inside of jail. Two different things will happen. Different rules, right? So that's your end of the rainbow for the 2. Come on. So I'm going to say, do you got some work to back it up? The correct answer. Some work to back it up. The correct answer. And we'll leave that 1 as a floater. For, look, I did all of that, but I just said 2 plus 4 is 8. Oops. Still something out of 5. Okay. So, we're kind of rounding out the quarter there with a little bit of review. We reviewed all the packet stuff on Thursday. Today, we need to make sure we got this graphing thing down. Because even after spending, 2-3 days on it, it looked a little sketchy. Where we're not quite sure how to make our table. Huh. Who what? Yeah, so long as you're... Yeah, that's what they're for. Not just something to distract us so we don't have to pay attention. Okay. Oh, yeah. You. You. I keep forgetting. You. And a pile for the kids who are gone. All right. So, this is just practice. Practice with, can I make a table to write the equation? There are 12 of them there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and me. Oh, that's serendipitous. Serendipitous, meaning everything came together quite well, almost as if it was destined to be. I am going to do a problem. And who gets to decide my fate? The dice gods will speak. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hey, AJ, pick one on there that you say, ew. Pick one on there that you don't like that I have to do. Said 27? Okay. I wanted you to pick one with a fraction. Good. Okay. We had a trick to doing these with a fraction. It was my table. And you know what? If you got room, if you can write small enough, not everyone does. Maybe write in a separate notebook. X, Y, and in the middle, write -1/4 x plus 1. See, if I do the same thing every time where I'm plugging in the number, maybe I should have the math to back it up. 1/4 times the number plus 1. -1/4 times the number plus 1. -1/4 times the number plus 1. Now, I'm okay with you doing this in the calculator, but sometimes it helps to see it written out. Sometimes we don't have a decent calculator or don't know how to run the one we got. So there were 3 stages to this. Stage 1, I got to pick numbers for my table. Stage 2, I have to either do the math or run the calculator to know what comes out of this. Stage 3, I have to know how to plot the points. Those were the 3 steps to graphing these. And we told you that there's a handy dandy cheater for what to put in here. Because it's a fraction in front of x, I should be picking numbers that are multiples of 4. Because if I don't, I'm going to end up with nasty fractions. So just count by 4s. Also, another really easy one is always jam 0 in the middle. Because 0 is the easiest number to work with. What's anything times 0?
0.
Plus 1.
1.
There you go. So I've got the point 0, 1. So no left or right, up 1. I know that that's a point. On either side of that, I want to pick numbers that are multiples of 4. So just count by 4s. What's the first number?
4.
4.
8.
So I also want to choose 4 and -4. And then, you said 8?
Yep.
And -8. Okay. So 4, what's a quarter of 4?
2. 2. 1.
Here's 4 fingers. What's 1/4 of my 4 fingers?
1.
1, right? But it's a -1/4, so -1 plus 1. 0. Now let's say I just don't feel like thinking right now. Boy, it'd be nice if I had a calculator that did that for me. Ignore all that. Don't worry about it. -1/4 times 4 plus 1 is. Okay, let the calculator do the heavy lifting for you. Now let's say I don't know where the fraction feature is on my particular calculator. You can always use parentheses and say -1 divided by 4 to say -1/4. Then jam the 4 in there. It's still going to give you the same thing. Okay, parentheses are good stuff. And you can keep using it if you're on a right view calculator, because you can just highlight that thing and say, yeah, but what if it was an 8? Cool. Which is exactly what we just had, right? A 0 and then a -8. We did a 0 and then a 4 and then an 8. And when I plug the 8 in, we got a -1. Can you see the pattern out of this? So when I put in -4, what's probably going to happen?
2. No.
Run your way up. if not, grab your calculator, press buttons. What is, yeah,
2.
it is 2. Take -1/4, and you don't have to be a whiz with the calculators. You can just say -1 divided by 4 is a thing. I'm going to take that times a -4 times -4. Then I'm going to add 1 to it. You can do the order of operations. You don't need to one-shot it. Okay? I know we got a lot of gamers in here. Who says that you have to get the pink mist? Ugh. Can you just keep throwing lead downrange until they're gone? And take out half the level with it, but they're still gone, ain't they? You can do it in stages. You don't have to just kill the problem dead in one shot. Do it in pieces, just like this. So now I know that's a 2. Do I see where this is going? What's probably going to happen the next time? Poke buttons on your calculator. It is 3. Prove to me it's 3. You all got a calculator. Use it. I'm going to tell you, get used to using a calculator that is not on your phone, though. Because I'm fine with us using those, but you don't get it on test, do you? No, your phones are over there on the bench or on the counter during our quizzes. You want to be using a calculator that you are going to use on a regular basis. And come to think of it, I think we got, someone left one in here the other day. Yeah. These were just left in my room the other day. If someone just wants them, take one. Okay. I should be able to say -1 divided by 4 is -1/4 times a -8 plus a 1. I can do it in stages, or if I got the calculator mojo, I can type it in one shot. Okay. Now I've been saying this all semester. Kevin, that Casio you got there, I've been in love with those things for 15 years. You can get it for like $9, $10 at Walmart. And that thing will almost do your taxes. That thing's great. Like it'll do some forms of regression. It'll do derivatives and integrals from calculus. Like it'll do some funky stuff. It'll simplify radicals for you. Remember that? Okay, you just type square root of 180 in there and hit enter. It spits out 6 root of 5. Oh, they're nice. Okay, now I understand, not everyone's got the $9 or $10 to do that. Not everyone can go over to Walmart to even get that. Not everyone's going to remember it. Okay, you're going to need a calculator. Like if you want to make it through high school, you're going to need a calculator. Talk to someone, myself, one of our resource room teachers, guidance office. We can get you a decent scientific calculator if you can't get one on your own. Okay, you should never have to pay a cent for public school. We got you covered. We just got to know who needs the help. But no matter what, you press the buttons, you're going to get 3. Stop that. There we go. Now, if I'm going to graph this right here, what even fits? Because if I try to do -8, 3, well, 1, 2, 3, 4, 5. Crap. Ran out of room, right? So I can going 3 boxes off road is getting a little shady. If you're neat enough, maybe. Could I go by 2s, right? Could I do that? How many times did we run into a different scale? Maybe I put these little tick marks here to show myself that I'm going by 2s. Sneaky, sneaky, right? Because now every box is worth 2. Maybe I need to write a reminder next to this to tell myself X then Y. I need to tell myself X's are minus then plus, Y's are minus then plus like this, so I know which way to go. Because now when I see the coordinate negative 8, 3, now I know I'll go back 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3. Now I don't actually draw this L, I'm just putting that on there so you can see what I'm doing, what I'm counting. Okay. And keep doing that. Back 4. 1, 2, 3, 4, up 2. 1, 2. Back, not, 0. That's no left or right at all, but I'm going to go up 1. Positive 4 in the X spot means I'll go right 4. Over 1, 2, 3, 4, 0. So no up or down, just right there. And finally 8. 1, 2, 3, 4, 5, 6, 7, 8, down 1. If you do it correctly, they should be on a line, because everything on this page is on a line. Get a straight edge. Don't wing it so it's trash like mine. Y'all got a straight edge at some point. Edge of a notebook, an ID. Okay. I've had kids use the edge of their phone case, edge of a notebook, calculator lid. I've had really clever kids before line up the edge of a pencil and then just use another pencil. Right. Hey, it worked. Kevin, pick one more that I got to do. Kevin says 33. Okay. Now, I can get rid of the fraction part with x, but when they go and add a fraction onto it, I'm just stuck with fractions. Okay? So I'm going to have to kind of ballpark stuff as to halfway through a box. Oh, hey, get down here. So, just like last time, I'm going to pick x's that are divisible by 4. I'm going to choose -8, -2, 0, 2, 4. And I'm going to get the y's that go with them. I would like for, we got 2, 5, everyone press the buttons on your calculator. Ha 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 ha. I would like you to put in -8, -4, +4, +8, -8, -4, +4, +8, -8, +4, -4. Okay? I want you all to plug a number in there so that we're all getting the same thing without having to do the whole thing.
So plug in a number.
-8.
So plug in a number to the number that we would be in.
Yes, the number I gave you, plug that number in. That way we're not all having to do the whole table. Make this go faster. You're putting -8 in for x.
I know that. Oh.
Putting it into the equation.
Put it into the equation for x.
How would you put that into
Plug your number in. Depending what calculator you're using, you might have to go bonkers with parentheses. Bud, type this with a -8 there. Okay, for those of you who are using the bumblebees in class, alpha y equals. That gets you your fraction menu. Alpha y equals gets you fraction stuff. Hit enter.
Thank you.
Alpha y equals, if you're using the bumblebees, gets you fraction stuff. And it makes life so much easier. Okay? Parenthesis mode, if you're cool with it. If not, check this out. Alpha y equals brings up shortcuts. Hit enter. Start typing, right? Did you get it? Okay. So, yes, you can use parentheses and say that -3/4 is -3 divided by 4. Close it.
Okay.
Parenthesis, you were plugging in -8.
Yes.
Type -8. Close your parenthesis. Plus, now you're going to do 1/2. You don't know how to do it, so the fraction stuff, so parenthesis 1 divided by 2. There you go. Okay, write it down in the table.
6/5.
6.5. Okay. What I was saying is you can type this same thing if you use alpha y equals. It gives you this little cheater menu that gets fractions.
Oh, okay.
So now I would do -3 arrow down 4 arrow over parenthesis.
Okay.
Like it's the same way plus alpha y equals another fraction. Like this thing will. These calculators are gonna do stuff, and you're like, Why is it different? Why is it different? But if I change that into a decimal, it's the same thing. These calculators, honestly, 3/4 of the stuff they do, even my pre-calc doesn't use. Like, these are overkill for our class, but it's also what I have on hand. Yes. Yeah.
Yeah,
Yeah.
it doesn't look right.
Because it was written as a decimal instead of a fraction.
Oh,
That's okay.
okay. How do I read that then? Since it's a decimal number.
3.5, literally.
Is it okay?
3.5. So if you're plugging in a -4, so back 1, 2, 3, 4, and then 3.5. 1, 2, 3 and a half.
Okay.
Okay. And that also works for when you're typing it in. Maybe you don't like this. You could type that as -0.75 by thing plus 0.5 by thing.
No. Okay.
Right? Now, that doesn't always work because sometimes it's not a nice decimal,
Yeah.
but it will work here.
Okay.
What? Yeah. What? What about Walmart?
Yeah, well, I need it to be walking distance. Yeah, Dylan, you're not quite in walking distance at Walmart. Like you can walk there, just take a long time. I'd rather dive than work at a fast food place.
We can't think about it. You have to have it.
I mean, it's not that bad.
Unless it's Subway.
What was your number?
I could get free cookies.
Grocery stores are always looking for stalkers. Like, not creepy stalkers, but stock shelves.
Dude, Walmart pays so good to stock.
I can't have a job unless I have all A's and B's, and I don't want to get like that and lose my job a week later. So it has to be close to here.
Why? What are you making money for yourself? How would you do that?
Yeah, if you go like to Walmart, you buy
Because the priority is to get.
Okay, good, great. Like,
Now, the whole we're going to ruin your life if you don't have straight A's or A's and B's, I disagree with very much.
oh yeah.
That sets very unhealthy expectations for a lot of kids.
That's why I don't care about school anymore. That's why I'm failing. Oh my god.
But that's a topic of discussion for another time. The -8. Dylan, what'd you get?
I think 6.5.
Okay. Who else had the -8? Right? And I think it was Kevin. Okay. 6.5. Okay. The -4. It was Geneva and Chloe, right? And Paxton.
-2.
Oh, -2. Sorry, not -4. No. Why did I write -2? Why did I write any of this? And why did no one call me on it?
Wait, Paxton did notice this, so is that a brownie point?
Did he say anything? Did he correct me?
Yeah, he actually did.
Did you ever have any interaction with me?
Yeah.
He said,
No.
Why is there a? He said, "Why is there a -2?"
Yeah.
Right now. Right now, yeah. All right. I'll give it to you. Okay, the -4. What'd you get? What'd you get? What'd you get? What'd you get? 7/2. Now, did you get something different? What? I would like you to take 7 divided by 2. You still have 3.5 right there? Don't touch anything else. Does it still say 3.5? Hit the math button. The very first option is change it to a fraction. Hit enter.
These are so
Hit enter again.
hard.
No way. So yes, you're both correct. 7 over 2, 7 halves, is 3.5. See, and now it's not the same color, and it's going to bother me. I didn't make anyone use 0 because what's anything times 0?
0.
Plus a half. 1 half. Okay. And since most of us seem to be going to decimal town, I'll just use that too. Okay. What if I put in a positive 4? So who had that? It was Shane, Paxton, AJ. If I put in a positive 4, what do we get?
I got negative 2.5.
Negative 2.5? Or maybe it said negative 5 halves, depending how you typed it. And 8. Positive 8. We had Micah and Gavin and Hannah, maybe? What do you get?
Negative 5.5.
You see the pattern, though? How it goes down 3, down 3, down 3. Like if I have 50 cents and I want to buy something that costs $3, I'm in the whole 250. Down 3 again, every time. Okay, now how do I fit this on here if, ruh-roh raggy, I only got 5 boxes in every direction? Exactly what we did the first time, right? I'm going to put a bunch of tick marks in here to say I'm going by 2s. Now we're in business. So we say negative 8, 6.5. That means left 8, up 6.5. Left 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2, 3, 4, 5, 6.5. Right? Because halfway through the box is 7. So I want to be halfway between 6 and 7. Yes?
Wait, so like, why wouldn't those be the same as the top ones for negative?
Because they're not balanced around the point 0. They're balanced around the point half. Kind of like a teeter-totter where maybe you've got 3 little kids over here and one of the 8th graders over here. Right? They're not going to look the same, but they're balanced. Okay? It's balancing around a different point. Now, let me get all the points up here, and because I have Smartboard and you don't, I can show you things. Okay? Now, back 4, up 3.5. So back 1, 2, 3, 4, up 1, 2, 3.5, halfway between 3 and 4. And you keep doing this. No left or right, but up 0.5. Right 4, down 2.5. Right 8, down 5.5. Right 8, down 2, 4, 5.5. Connect the dots. Use a straight edge so yours isn't all weebly wobbly like mine. Okay. Now Riley asked a pretty good question. Says, why isn't it just the same positive and negative? There's the fulcrum. There's the middle of the teeter-totter. It's balanced around that point. Look at what happens to all of those points if I move this down a half. Now, right 8 down 6, left 8 up 6. Everything was off by 0.5 because my middle was at 0.5. That's literally what changed it. Okay. We're going to kind of beat that to death second semester. We're talking about lines. I know that graphs and lines didn't really go so hot for you last year. Or no, we might even do a little bit of that before the end of this semester. I don't remember. I think it's next semester. So the fraction ones are super tough. What I would like you to do is ignore 32. We already did 33 and 27. I want you to do the other 10. Yeah. Or 9. Yes. You got 9 problems. You have 30 minutes. And we just did the ugliest ones on the page. Make a table, plot by points. Let the calculator do the heavy lifting for you. Next to each one of these. You know what? I'll even tell you. Ooh, I'll do one more just because maybe we haven't seen these in a long time. If I see a graph like number 28, y equals 2. Think about that as a table. These type of problems are like the Groot of math. What if x is negative 2? I am Groot. What if x is negative 1? I am Groot. What if x is 0? I am Groot. It doesn't care what the x is. Y is always 2. That is its answer every time. So 1, 2, 2, 2. So if I put a point at negative 2, 2, negative 1, 2, 0, I am Groot. 1, I am Groot. 2, I am Groot. When you connect the dots, it's just a horizontal line. We expect them to be more complicated than that, but that's really it. In fact, next to 28, you got a little room off to the side. I'd like you to make a note to yourself. If I ever see y equals number, it's a horizontal line at that number. If I ever see x equals number, what might be different? There you go, vertical line at that number. Okay. There you go. Now, see, now we're down to 8 problems. Get them. If you're working, yes. If you're screwing around with your device, claiming I'm just finding a song, no. Because let's all be honest, you're never just changing your playlist, and it's never mom that you're texting. So, you got time. You got plenty of it to do 8 problems. Yes. Yes.